Hello everybody, and welcome to today's presentation, Distributed Monitoring, How to Understand the Chaos Created by Microservices, brought to you by InfluxData. I'd like to introduce you to our presenter, Gianluca Arbezzano. Gianluca is a SRE at InfluxData. He is a big open source contributor for several projects, including opentracing, Docker, and InfluxDB. He is also a Docker captain and CNCF ambassador. He is passionate about troubleshooting applications at scale, observability, and distributed systems. He is familiar with several programming languages, such as JavaScript and Golang, and is an active speaker and writer, sharing his experiences and knowledge on projects that he is contributing to.
Thank you everyone for being here. This is a presentation that I'm building based on experience that we are doing as a SRE at InfluxData and from all the people that I speak when I attend conferences or when I work in the open source. So it's really driven by needs from development and from experience. First of all, I'm Gianluca Arbezzano. I work as a site reliability engineer. I have a blog and I tweet about cloud computing and observability and gardening also. So when I'm not doing hacking or writing code, I'm happy to stay outside. I have a garden where I grow vegetables, and I like to travel for fun and work. So that's why I'm very happy to attend conferences as well, because it's a good way to join these two stuff together. So this is me in Dublin, where I lived for 2 years making homemade gnocchi. I'm at the Azores looking at a tree, thinking about how microservices works and how to observe them. And here is myself in Cuba, that I'm looking at the horizon, trying to figure out how metrics and traces works in our system. And I'm actually asking myself here, what's happening in production right now? So this is the main questions I always have. So this is me during my first ride. So you can see that the horse is very small compared to me, because this was my first time doing a ride. So they give me a really quiet and small one. But I'm using this as a metaphor, because we're going over these slides together, this experience, to learn from each other experience. So feel free to leave any questions, because I'm happy to answer them. A little bit about InfluxData and what we do, because I think it's very important when it comes to observability and monitoring. So we do a set of open source tools that stack together, allow you to have a monitoring stack. So the most famous project is InfluxDB. It's a database that you can use for time series purpose. So it's built for time series. Other than that, we have Telegraph, that is a collector that you can install in your servers. It's an agent that you install there, and it has a lot of input and output plugin. Input plugin are made to scrape and get metrics from the system, and output plugin are made to store those metrics to a particular storage. InfluxDB is just one of the supported storages. Chronograph is our UI, so you can use it to query, to do dashboard, and to manage alerts. Capacitor is our alert manager, but it's way more than that. It's what we made when we learned that you should do something with your metrics. So with InfluxDB and Telegraph, you're able to store and get metrics, but the power of them is when you take action, and Capacitor is the tool that does that. It does batching and real-time streaming processing of the data that you have in your InfluxDB. Obviously, alerting is one of the traditional way to use your data, but there is a lot more that you can do, like anomaly detection, machine learning, and so on. So another important stuff that I need to share about myself for what matters in this presentation is that I come from a development background. So I started as a PHP developer. I made some mobile application, and now I'm working in Go and as a SRE, because I made some experience with AWS, and I got in love with all the automation side of the world. So that's why I bring my experience as a developer, and I moved that to ops. But it's also important the opposite, so the other way around. My experience in operation made me a really good developer. And I think that the site reliability role and what we are gonna see today is about this kind of experience. So how do you bring those two stuff together? Because with both of them, operation and development, you can be a good developer or a good operator. If you don't have both of them, it's not the same. So microservices are not the unique distributed system. Usually those two concepts comes very close to each other, but just because now everybody is moving to microservices. But in reality, distributed system means way more than microservices. Microservices is just one of the distributed systems that we can work with. Others are queue systems, for example. I see them as a distributed system because there are more actors inside a single system. Is not just a single application that works by itself, but there is more actors inside the system. The same for multi-thread application. If you have an application that does multi-threadings and leverage multi-threadings a lot, in some way it is distributed. Obviously, it is not distributed in the network as we usually think with microservices. It's distributed over threads, but it is still a distribution. Third-party services are also another way that I see distribution. So today, startups and companies relies a lot on external services. I'm thinking about House Zero to manage users authentication, or other system that you leverage to match your needs, your business needs, because we can develop everything. So microservices is one distributed system, and there is a lot more going on. So more a distributed system is, and harder it is to understand. I think we are used and we kind of know how to troubleshoot and understand what's going on in a monolith. We can always take logs and see how they works. But in a distributed system, it's hard because containers are everywhere, pods are everywhere, your application is not in the same place, so you need to know where it is, and you need to know what you're looking for. But usually you don't know what you're looking for because you're having trouble and you are not able to understand the problem. So this creates frictions, and we need a new set of, I don't think tools is enough. We need tools and a new mindset to leverage this kind of problem. Dynamicity is another source of complexity. So distribution is one of the reasons why everything looks more complicated than what it was before. The second one, in my opinion, is also dynamicity. And dynamicity, we have a lot more, we live in a lot more dynamic ecosystem, mainly because we leverage cloud computing. Even if we are in-house and we have a private cloud, I still think that it brings a lot more complexity and a lot more distribution than what we are used to be. Containers are definitely huge in this sense, and Kubernetes is the orchestrator that everyone uses now. But the real problem is that when you switch from a more traditional environment to cloud computing, you start to see that IPs, host names, MAC address, or whatever you was using before to figure out where your application was, doesn't apply anymore, because containers goes away and come back automatically with Kubernetes. Cloud computing gives us the ability to do a lot of automation. So IPs, they change every time a container change. The host name change every time we spin up new servers or we retire AC2s. So it's we don't really have any stable point of view anymore. So I think that cloud computing plus container is just like a nuclear bomb that changed how we was used to see and monitor the world. So as I said, all the traditional point of view or all the traditional stars, fixed stars that we had in the past are not working anymore. IPs, hostname, they go away, and all the capabilities and all the experience we made was based on this kind of strings. So this makes probably a lot of people scared, and I was scared as well, The best way we have to get over, and I bet there is a way to get over and be happy again, is to make your hands dirty. I started to change my mindset when we started to develop Cloud2, that is our new cloud offer that is in free trial right now, because we learned a lot how to troubleshoot a distributed system and how it works. And this is the unique way that we have to learn. So first of all, we need to remember that there are three pillars when we think about monitoring and observability. There are events that are regular or irregular. Regular events are the ones that we scrape in a fixed amount of time. I'm thinking about CPU, memory, and all the system stats that we take from the system every 10 seconds. These kind of stuff are regular because we have a time, we have a range, and we get them and we store them to a storage. Irregular time series are time series that we can control. I mean, if you measure the number of login or the number of page view, you cannot really ask your customer to log in every second. That would be weird. So those kind of events that comes randomly from system are irregular. We all know what logs are, and traces is just a new way to aggregate events. And I'm going to show you what I mean with traces later. So we need all of them to have a good understanding about a distributed system. Metrics for me are like a slap in the face. So during the night, you get a call, you get a page, you wake up, you open your metrics, your dashboards, and you see a spike. And that's it. At this point, you don't know where to go anymore because you see a spike, but the spike doesn't really tell you anything. It just tells you that something is not right, but what does it mean it is not right? This is where I think we are switching from monitoring to observability. Monitoring is great because we need a way to understand how a system works and trigger alerts, but after the alerts, we need more. We need to observe a system, we need to troubleshoot it, and we need the tools to do that. We all know how this guy is feeling. This is a demon from the past. So I used to have a colleague that was really, really good at troubleshooting system because he was tailing logs and he was looking at the speed of the logs. If the speed was very, very high, so if the logs was really, really fast, it means that the application was under load and it was not working well. If the logs was not fast enough, it means that probably something is broken. So we should do way better, but this is the feeling that I have the feeling that a lot of people still do that. Like you take logs, you see how fast they are, and you try to figure out if they're good or not. I think in some way, I'm just realizing now I'm speaking that this is a kind of an observability way, but we can do way better than that. So traces are the last piece of the puzzle when I think about the distributed system. So you see your metrics, you get that there is a spike, now you go in the logs and you see what happened in that range of time. But now you need to understand what happened for one particular request. Because when you are in a microservices environment, it's very hard to understand and to realize where your application goes. Because you can have, hundreds of microservices. Your request can go to 10, 20, 30 different applications at a time. And you need a way to track your request since the beginning to the end and understand how it goes. So the secret, I'm going to tell you a secret here, is not about the single metric or the single trace or the single log. It's about how you combine them together. And I think this is where tooling plays a big role. As I told you at the beginning, there are two things to do. One is the mindset change. So we need to understand that and try to figure out what happened in a distributed system is way different than what we are used to do in a single monolithic application. The second is about tooling, and we need tools that help us to combine and switch from logs to traces to metrics. A trace describes every specific request from the start of it, so from your client or from the edge, from the first front end to the storage and back to the user. So with a trace, trace gives you this ability. And the ability is made by correlating events using a unique ID. So let's imagine that every time your application, your customer sends a request, it gets an Nginx, and the Nginx is able to create a trace ID, and the trace ID goes propagated to all the other servers. And in some way, you have a visualization that looks like the very good painting I made in this slide. And this is the way you tell the story about every specific request. And usually when we speak about TCP protocols, so HTTP requests, the way the information gets propagated is via HTTP headers. But if you are in a queue, for example, what you can do is to embed the trace ID, the span ID, and all the other information that you can have in a trace, and that we will see later, in the payload of the message. So in some way, there is nothing magic. You need to generate a trace ID, and you need to propagate this trace ID through the system. Based on your languages and based on your infrastructure, like if you use Service Mesh and Envoy, it gives you some utilities to do that and it makes that easier. But in any case, to go to the foundation, to the fundamental point of tracing, you have an ID and you need to pass those ID through all the system. The questions that a trace can answer are like this. Why my request failed? How long a message takes to be processed by a queue? Or how many times the billing service reaches a particular other server? So yeah, how many times the billing service reaches the out service for a particular request? So for these three questions, the important part to remember is that you are observing a single message or a single request. So you are not looking at some sort of aggregation or some sort of sampling. You are looking at one specific request in your system. And if you are able to design your pipeline or your user experience to teach your customer to speak with you or with your support team with that trace ID, it will be huge in terms of troubleshooting, because the trace ID is like the sign, the unique ID that you have for every specific request or for every specific or for one specific message in the queue, for example. Other than that, as I told you at the beginning, traces are just a different kind of aggregation, but in row, they are just point in time. So point in time can be aggregated. So you can do aggregation, like asking the questions, the average time that your Amazon controller, that is a random application, communicate with AWS, or how much time the billing service spend speaking with the out service. These kind of questions are the question you can answer with traces. Once again, it is all about aggregation. So a single signal is not enough anymore. I think if you are in operation and you write your alerts, you will probably realize that if you do an alert on one single signal, so let's say the CPU usage, you will get a lot of false positive if you are in cloud or in a container, mainly because there is a lot of complexity around automation and to keep the system balanced, that you don't really need to wake up during the night if the CPU goes over 80%, because you have the automation to scale up or down the number of ACQ or the number of containers. So you need to wake up if a business goal is is having issue because maybe an underlying service isn't happy, or the latency is too high, and the automation that you have is not able to solve the issue for you. So in order to have good alerts, you need to have and do good aggregation, but it's very, very hard. One of the ways to make it simple is to instrument your code. I think that code instrumentation should be a first citizen in your code base. So if you're used to do random printf or random echo inside your code as a log, I think you should think about something different, because the information that you get from the application are crucial to understanding what's going on. So what I say is that metrics and logs are the way your application speaks to the outside, and the responsibility for having a clear language between your application and the outside is for the developer and for the operation. So we are the person that needs to make the instrumentation code good. So that's why it needs to be a first citizen in your application. There are a bunch of libraries that has a goal, final goal, this idea of instrumentation. Opentracing is one. Opentracing is a project developed by a bunch of people in the CNCF, the Cloud Native Foundation, and it is a standard to instrument your application in order to send traces. So this is an example in Go. So you have a function and you start a new span from a previous one, and it gives an operation name. So every span is one of the bar that we saw in the tracing slide. So when you see a trace, you have a lot of bars, and in the opentracing dictionary, a bar is called a span. So you can attach to a span a bunch of stuff like tags, and tags are key value store that you can read from the backend. So in this case, I'm supposing to I'm like mocking a SQL server. So this I'm adding as a tag the query that I'm running. But you can also add as a tag, for example, the user ID. Other than that, you can also attach logs that looks like event in the span scope. This is a slide that I took from the opentracing website, just to give you an idea about how a tracing infrastructure looks like. So you have all your application. It can be a lambda function, it can be a RPC, it can be an application, and you instrument your application with the opentracing libraries. In the opentracing libraries, you can inject a concrete tracer, a concrete backend, that is the one where all your traces will be stored. There are a bunch of them. Some of them are open source, like Zipkin and Jaeger. Zipkin is an open source project developed by Twitter, and it is in Java. Jaeger, as I told you, is developed by Uber. It is donated to the CNCF, and it is in Go. But there are also a lot of other closed source or as a service traces like Step, AppDash, Instana, Honeycomb, and so on. So the idea behind opentracing is to give you a framework, a library across many languages that you can use to abstract the concrete tracer. Because you will sooner than later realize that there is a lot of complexity around instrumentation. The instrumentation code, when you think about tracing and logs and events, will be a lot. So if you need to change the instrumentation code every time that you need to change the tracer or the backend where you store all your metrics, it's going to be a very, very big and huge task that you should try to avoid. So all this open tracing, but also OpenCensus, it is another library powered by Google, is a way has as a goal the idea to give you a library that you can use to instrument your code, so a friendly API to instrument your code, and it abstracts the concrete backend that you would use. At InfluxData, obviously we use InfluxDB, and we use Jaeger as a tracer. Back in the day, we forked Jaeger. Jaeger supports a different set of backends, like Cassandra, Elasticsearch. InfluxDB wasn't part of the supported storage. So in order to have it to work for ourselves internally, we forked it. A few days ago, the Jaeger community released a gRPC storage plugin that is very useful to hook other storage that are not supported natively by Jaeger. So what we did is to wrote our own implementation of InfluxDB as a gRPC storage, and now we are able to ship ship traces to InfluxDB. So the project is still in development because we are moving from the fork to this new wrapper, but it's there. You can try it, and we will write about it more in the next couple of weeks for sure. But we are using it since a couple of months, and it's working great, at least in the fork. The reason why we develop and why we need internally tracing and InfluxDB as a tracer is because I made a couple of tests back when we didn't have the Jaeger implementation with Zipkin and MySQL, just because we rely on traces because they are very useful, but they are also super expensive to manage because they are high cardinality data. Because you need to think that every request generates a new ID, and this new ID need to be indexed. So the index grows a lot. So the tracing is one of the highest cardinality data that I ever saw. So you need a database that supports high cardinality data. I was very looking to have retention policy. So retention policy is one of the core features that InfluxDB has, and it is the ability to remove data that are older than a particular time, like a week, in a very good and efficient way. So traces are really expensive to store, even for InfluxDB, because InfluxDB is time series. It's not a magical time series. It still has all the physical rules that databases have. So the disks are full of time to time. The index grows too much. So you need to keep the database clean. And I leverage retention policy, and I leverage the fact that spans are really time to live kind of. The time to live for a span is very, very low, because you need a full trace for 1-2 days until you discover there is a bug. But after like 3-4 days, you can remove older span and older traces. So that's what we do. We keep traces for 3-4 days, and we remove the oldest one using retention policies. And obviously from Jaeger and Zipkin, you can download the JSON representation of the traces, and you can load it later. So what we do usually, we download the trace, we attach the trace to a issue when there is a bug, and in this way we can keep the trace safe, and we can use it, and we can load it later when we will troubleshoot that issue. So if you never used Jaeger or Zipkin, this is how they look. You have a list of trace, and you can click on one of them, and you can see all the span for one particular trace. So in this case, we are tracing one particular request in the storage. We are instrumenting the actual code. So what we see here, we set variable as a tag, we have the line of the code, and all this kind of stuff. So we are inside the code. The good stuff about having InfluxDB as a backend is that you have the point as a point in time. So you can query them like you just do for all the other metrics. So you can query traces just like you do for CPU, memory, Docker events, and so on. So in this case, you can count how much time is spent from a service A to speak with service B, just making a summarization of the duration for all the spans. So you have all the capabilities that you have because they are time series, and having them back to InfluxDB is great because you have all the ecosystem of metrics and time series that InfluxDB provides. Another application that we trace is our orchestrator for Cloud One. So Cloud One is the SaaS version that we currently sell, and we rely a lot on AWS, and we do a lot of AWS requests to provision new cluster for the customer. So as you can see here, there are two traces. This is a real story, and if you look deeply, you will see that the register instance to ELB span has, in the left, 3 childs, 1 from the AC2 service and 2 from the ELB v2. On the right, on the right, you have the register instance to ELB to LB, but there are just 2 requests, 1 for EC2 and 1 for ELB v2. So this was a bug that we quickly discovered just using tracing, because we was able to figure out the customer that had the provisioning issue, and from the customer ID, we took the trace ID for the creation request, and we compared that specific request that was failing with one that succeeded, and I was able to figure out that, oh, there is a missing request to the ELB v2 service. So there is where the code should be fixed. So I jumped there and we fixed the issue. So tracing is a debugging tool, and it's not just for production. And this is the main difference between monitoring and observability. Monitoring is very coupled to production. You do not really do alerting for staging because nobody cares. Observability is a set of tools and practices that are usable every day during your normal work. So for example, in my case, I have always a Jaeger tracer on my local laptop because I look up for traces to figure out how a feature that I'm developing is performing. So it is not just a production issue, and it's not just a production tool. It's something that you use every day. And this probably looks very minimal as a approach, but it makes a huge difference, because when you do monitoring, you use your dashboard, you use your metrics only when there is a problem, or often only when there is a problem. It's very unusual for somebody to look at the dashboard when there is nothing going on, because when there is nothing going on, you have your code to write, you have other stuff to do. You get in the dashboard when there is a problem. With observability drives you to use metrics, to use traces during your normal day work. And this is a game change because you get used to them, you know where to go when there is a problem, and you don't look at the dashboard as a exercise anymore, but it's really something that you rely to understand how a system performs. So this is an example of what we trace. So this is, I clicked on one of this bar here, and when you click on one of them, it gives you this visualization. You can see the key value stuff, and the key value stuff are the tags that I showed you before. So as you can see, for this specific application, I'm tracing everything I can, because it is not really a high traffic application, but it's very important for us to have all the information we can have to troubleshoot a problem when it happens. So it's not a matter of high traffic, it's a matter of precision on troubleshooting an issue. So we have a lot of tags, and as you can see, we trace the body of the request and the body of the response as well, because we really need to have the full picture of what's going on. So I'm back saying that a trace can be, and you can see here, a very, very, very expensive kind of data. So you should really think about sampling them. And a lot of tracers like Jaeger and Zipkin, they have a sampling capability inside the library itself. So you can say sample half of the request, or sample 20% or 10%, or you can base the sampling on the header, for example. So you can send a request that should be traced and the other one shouldn't be traced. So there is a nice presentation about Twitter about their use case. They was tracing a cache system, and they was able to understand, to troubleshoot a problem when they wasn't hitting the cache when it was supposed to be hidden. Because a trace tells you when you hit the cache and where you do not hit the cache. So you can compare them, and you can figure out if there are anomalies around your logic. So there is a lot that we can say about tracing, about instrumentation. I left a couple of links and credits about all what the people does, because one of the key things I learned is that either if you are Google or Facebook or a big company, you need to rely on a community, because we write application in a lot of different languages. So we need to cover all the different languages in order to have the same instrumentation experience over all of them. And this is hard to do by yourself. So that's why there are communities that are starting to work around how to instrument your application. Opentracing and OpenCensus are just one. And I left here in the links an article that mentioned that they will be merged together. So OpenTracing and OpenCensus will become one single library, and that's a big move. So I spoke about logs briefly, and I told you that you shouldn't think about logs just as a printf that has no value. Logs has a huge value, and in order to give you something good to read, there is an article from Honeycomb about how structured logs works. So the idea is that logs is not anymore a message that you print in the standard output and you forget about it. The log is something that should be parsed and should be converted to events, and you should use them to do aggregation, alerting, and so on. There are a bunch of other articles and links about open source tools that I think you should have a look about these topics. So thank you very much for your time, and I think that's it.
Great, thank you, Gianluca. We had a couple questions that have come in. So the first question that we have is, which programming languages have been used in the platform's development?
As an InfluxData, we use Go for almost everything. We also have something in Java using React, like Chronograph is made in Java. So those are the two languages where I have most experience with in tracing. But I also developed a workshop that is in my GitHub account. And for that workshop, I instrumented a microservices environment that I mocked. And it is made by 5 different microservices in different languages like PHP, Java, Go, JavaScript, and something I don't remember. But so there are libraries provided by OpenCensus and OpenTracing almost for every languages.
Awesome. We do have one more question. So audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, what about archival policies for the data? Is there automation for that?
These are very nice questions. And the good fact about having your traces in InfluxDB, as I said, is that you get all the benefit that you have from the InfluxDB pipeline. So in our case, my suggestion is to use Capacitor to do sampling of the traces. as I told you, they are very expensive, so you can't really leave them in InfluxDB forever. I think you can leave them if you have a big enough instance for maybe 2 weeks, but this is already a lot. And usually, from an operational and debugging perspective, you don't need them for that much time. But the archive can be created by sampling traces using capacitor. So as I told you at the beginning of the presentation, capacitor is our post processor for metrics. So it can stream on batch information from InfluxDB, and you can apply your code on it, and you can output the value to some other places. So in this particular case, I think what you can do is to set up a tick script that takes the traces from the database and push them to S3 or to a long-term archive.
Awesome. That was the last question that we have. So Gianluca, is there anything you would like to add before I close things out?
Yeah, have a look at the links I left, and let me know if you have any question, and try to play with instrumentation code, because it makes a good difference.
Well, actually, we do have another question that has come in. The question is, do you recommend some type of network segmentation to avoid tracing traffic interfering with regular operational applications?
Yeah, libraries are made to batch traces for some languages, for others no. But what you can do is to collect them with Telegraph, for example, and send them in batch all together. But yeah, it's very important if you have a monitoring system in-house, it's in general a good approach to keep it out from your production workload, because you need it up when your infrastructure is down to tell you that it is down, so it can be in the same place. And tracing is the same. Put the tracers out from your production system, or as far and isolated it can be.
Awesome. And we actually did have one more question come in while you're reading that off. The last question is, how do you compare InfluxDB with Prometheus?
Actually, I don't really compare them that much. What I like about Prometheus, and what we use internally from the Prometheus ecosystem, is the endpoint. So I really like the slash metrics approach, and the fact that you can, from the application, expose metrics in a way that can be scraped from everywhere. So this is really what I love about the Prometheus ecosystem. And with the InfluxDB stack, for example, with Telegraph, you can scrape metrics from Prometheus-like endpoints and push them to InfluxDB. So this is what we do, actually. All the application that we write has a slash metrics endpoint. We instrument them from internally with Prometheus, and we push them to InfluxDB, scraping them with Telegraph. So I don't really like to compare them that much. I like to see them both as a great way to do monitoring. Sometimes you need push because there are stuff that you can really pull. For example, traces are really hard to pull because the slash metrics endpoint will grow so much, and that the memory will probably not really work. So there are kind of events that are good to be pulled, good to be pushed. You need to have the ability to do both.
Perfect. The next question that we have is, how do you collate time series traces across multiple microservices?
Sorry, can you say that again?
How do you collate time series traces across multiple microservices?
Yeah. That's what we do. We instrument all the services with the opentracing library, and we collect them in the same tracers, and we read them. So yeah, another stuff that we will do is to sample them. That's something that we don't do yet, but yeah.
Perfect. And with that, I'd like to thank you, Gianluca, for a great presentation today. I would also like to thank today's sponsor, InfluxData, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.